Ladies and gentlemen, good morning, everybody. My name is Marco Luise, and I'm honored to chair this EUSIPCO 25 industry panel on, let me say, artificial intelligence. Thanks to the organizer for asking me to organize this. I don't think there's any need to motivate why we do have this panel and the subject of this panel. I don't have any statistics now, any count, but all of us, especially in the poster area, can witness how many papers either centered on artificial intelligence or using artificial intelligence in the different facets of research that we saw. How many are there? I don't have any statistics. And even if a presentation is not explicitly on artificial intelligence, you notice that at least one of the questions after the presentation was, can you do this with artificial intelligence, right? So I will not go any farther along this line. This applies, of course, this pervasive presence of artificial intelligence applies to our own research that we showed in here, but also applies to any other branch of our world and the whole world. So the idea today was not to go on and to go along the usual route that we have already pursued into the conference of research, of pure research, of academic research, rather to build an industry panel, right, to show how big companies like we have today represented by our distinguished speakers do apply in artificial intelligence and how they perceive the relevance now and the relevance tomorrow of such techniques. That's why we are all here today. And thanks again to our distinguished panelists that we have here and I will present one by one. Unfortunately, we will not have David Sedek. Will you please go to the next slide? We will not have David Sedek from Thales. He's been sick yesterday. He could not travel. He apologizes to all of us, to all of you. But the person we have today are more than enough. Starting from my left, our first distinguished speaker is from Huawei, and we don't need to present the company. Lu Lei. On my right, I have Petros Boufonos from Mitsubishi Electric Research Laboratory. And then I have Domenico Angotti from Open Fiber. So different multinational companies doing different business, most of them in telecommunications, Huawei, Open Fiber, and Mitsubishi does pretty much everything. Okay, so I will ask first our panelists to give a very short presentation. It's not a presentation, it's what they call a statement, what they think about the subject of the panel. Just 5 minutes, just a very, very short presentation. So I invite, please, Domenico to go up to the podium and explain in a very, very short time the vision of Open Fiber and his personal vision, because it is true that the persons that are here do represent a company and are here also for that. But they are experts in their field of the technology we are speaking about. And so also their personal vision matters a lot. So please, Domenico.
Okay, good morning. Thank you for having me here today. My name is Domenico Angotti. I work in Open Fiber. I'm a head of network engineering. And I will talk briefly on Open Fiber. Maybe most of you don't know what is Open Fiber. It's a broadband company in Italy, which is since 2016 is building future-proof, mainly FTTH, fiber to the home network in all the country. And we already reach a significant number of households connected with fiber, almost 18 million in Italy. And of course, the project will go on, as I said before, on the access side is mainly based on FTTH. We're providing 1 giga and 10 giga symmetrical services already. AI is a huge discussion. For us, of course, AI means different things. Myself, as I'm involved in capacity network, capacity planning of our network, we are seeing what's going on with the AI data, the data generated by AI. And this chart shows that in the future years, the percentage of AI data, artificial data produced by many means of AI, for example, the bots, the different bots, will be a significant portion of all the data in the network. So this is a challenge we are tackling, and to be able to face this opportunity, but also to upgrade our network consequently. AI for us means three things basically. 3 A's: automation, augmentation, and agency, depending on the level of collaboration or involvement of the human into AI platforms. Whenever the task is simply, easily stated, the outcome, the expected outcome, or we just train AI, and so it's knowledge base, and it's trained to perform some task on our behalf. And during the panel, I will show some examples of how we are already using AI in our processes, operational processes, but also in engineering. And the last chart is about, I thought about the importance to collaborate with AI and to be able to tap into this opportunity, and the way to get the most out of AI. And I thought about the importance of the AI literacy, the AI fluency. And many years ago, as we are in Sicily, the Magna Grecia, there was Plato in the Phaedrus statement giving some insights on already on the importance of what we call today prompt engineering. Thank you for your attention.
So please, Petros, it's your turn.
Hi, everyone. You can hear me? Good. So I work at Mitsubishi Electric Research Laboratories. We're part of Mitsubishi Electric Corporation. Oh, I can have a laser. We do everything, but we're not Mitsubishi Motors, we're not Mitsubishi Heavy Industries, but there's a lot of activity that the company is involved in. And as you can imagine, machine learning and AI affects everything that we do. In Europe, we're mostly known for air conditioning systems, maybe elevators and factory automation, but the parent company does space systems, transportation systems, everything you can imagine, we work on it. And specifically, Mitsubishi Electric Research Lab is the fundamental research arm of the company. We have a lot of PhD research and so on. What I want to highlight here is kind of the research areas we're doing. Of course, AI is at the core in machine learning, but computer vision, control optimization, robotics, signal processing and sensing and multi-physical modeling. The reason I'm putting all this list here in a panel for AI is that all these are affected by developments in machine learning and AI. We're exploring LLMs for robotics. We're exploring models for machine learning models for modeling physical systems, buildings, air conditioning systems, and so on. There's a big research and a big area of interest, and we've seen a lot of benefits from using machine learning techniques. Specifically in my team, we're doing a lot of machine learning in the sensing field. So far in sensing, we've been using a lot of models, very painstakingly developing models for signals, models for systems, models for the data. We want to be as accurate and as robust we can. The problem with analytical models is that maybe they're very data efficient, maybe they can give you good robustness guarantees and so on, but sometimes they can't represent the real world very well. So a lot of learning-based models have entered the field, as you've probably seen here a lot in the conference. And these have some issues, like they require a lot of data. And sometimes this data is not available. Maybe, Google can collect a lot of images and a lot of audio, but if you're talking about factory automation, you don't have data. Or you can't have enough data. Or if you need to run big experiments that collect very little data, again, that's a problem. So a lot of the work we are doing is kind of trying to use some modeling and some data to kind of exploit the best of both worlds. So try to look at physics-informed neural networks or model augmentation of the networks. And I think that's a very important and very hopeful area, very hopeful research in this area. Just following up on that, learning-based methods are a very powerful toolbox for sensing applications, and we use them a lot. We've seen a lot of good benefits. But for many practical problems, we know a lot. The models we have, in many cases, are very good, linear, nonlinear, and so on. So again, we don't have the data, and we try to use models and learning together to kind of augment and get the best of both worlds. So I'm looking forward to the discussion in the panel.
Now, Lulei from Huawei.
Thank you for inviting me to join this panel, and I'm very glad to present here. I'm Leilu from Huawei Munich Research Center. I'm the director of the Advanced Wireless Lab. And my title for the presentation, I hope can answer some of the panel's questions. So we think that we will benefit from the AI communication, but we need to consider how to build agentic and super intelligence framework. So from the Huawei is a communication vendor. So we will first consider now we will consider the next generation for the communication evolution. So from our side, this AI revolution leads into a new era for the 6G. So we can see here, based on the ITU definition, actually we already put AI as very important role of the future communication system. Besides this, we think that with these new, especially beyond communication technology like sensing, and also with this AI agent capabilities, we can more to let the network to be self-evolution, like the network can be based on the sensing result for the actions, for reasoning, and make the final decision to generate a autonomous network. So, and I think previous panel expert already mentioned about the AI for sensing, but from our side, we think if the network can provide the feature of sensing, I think, the physical world will be based on this new data infrastructure to enable AI. Why? Because if the network can provide such a big data source, and that can be benefit for the AI and also improve the accuracy of the detection and also reconstruction based on these sensing result about the environment. And another thing is that now we all think the network like infrastructure and provide the communication capabilities. But the future, we hope that we can do more compared with the communication, like these networks can be driven by the applications. So we think that if we can have this net agent and also this example agent based on the AI feature, we can planning the network connection, the network to provide more suitable for the different services of the network to enable the capability of the future networks. And maybe have a quick conclusion is that 5G is a success and 6G is on track. Now 3GPP already begins the definition of defines the study of the next generation of the communication system. Now AI plays a very important role both in the physical RAN side and the network architecture side. So thank you for your attention. Thank you.
So if you can show again my own presentation, please, the third slide, next one. Next slide, please. Okay, good. So now we go deeper into the subject of the panel. If you took somehow your time to go through the extended title of the panel, you notice that we have kind of a question. Artificial intelligence, hope, hype, or risk? Why is that? Here we are, in a sense, a little bit leaving our comfort zone of research and technical issues. But we are trying to look a little bit deeper and far away. First, I will ask each panelist the same question in a round robin, starting with Domenico again. You can read the question with me. It is related to the perception of artificial intelligence, because in the general public, artificial intelligence means building intelligent robots, means being able to chat with a chatbot. That's how everybody perceives artificial intelligence. For us, it is something different. For us, it is, I don't think it is a hype, but it is not even a hope, but it is a certainty, because in your industrial experience, you already to some extent showed how such techniques, machine learning, artificial intelligence, are already used and very, very fruitful in your everyday industrial life. So, starting with Domenico, the question is, can you cite examples of solid and fruitful application of such technology taken from your own experience and activity? Please.
Okay, in Open Fiber, since a long time, we've been following AI, and particularly now, we are starting to become more and more aware on the potentialities. And as I said in the introduction, it's very important for us to build the right culture and to work on AI literacy. So we started an overall program of training inside our organization to be able to tap into this opportunity. Talking about some practical examples of applications of AI in a network, I think that the best has yet to come, but we're already using AI for augmentation. It means that there's an opportunity out there using AI platforms to assist our technicians for maintenance in the network. So they don't need to have all the hard skills, but they are constantly assisted by AI, giving them indications on the procedures for network maintenance. There's already an application that we're working with some of our vendors is on fiber, a proactive analysis on fiber. We have a software that is embedded in our transport network that is able to detect proactively if there is a slight degradation in the fiber performance. For example, some attenuation is increasing. And so this is something that automatically, without the intervention, the human intervention, whenever the AI algorithm starts to collect the data and to analyze the trend analysis and see if this attenuation will go worse and worse, and then to alert the technician before there is a major failure impacting on the service and therefore for the end user customer, to be able to alert before there is a major fault in the network. On the operational, we already use AI also for automation, for provisioning, for example, commands, provisioning with the network for setting up the services for our network. So this is a clear example that you know the procedure, you know the steps to be taken, and the expected output. So it's the first element I've been showing before, the first A. But we're working a lot now on the agency, the agents. Personally, I think that based also on the analysts, what they are showing, I read a paper made by World Economic Forum, and there's an interesting picture showing the readiness and also the impact of the AI applications in the industry, in the telecommunication industry, on the two axes. And of course, this is coming also by what we see in the market and talking with our customers. We see that the AI applications are in more advanced phase for operational tasks, and also for interaction with the customers, and are lagging behind on the engineering and the design part. So the next challenge that we are considering, myself, I work in the engineering. At the moment, we are not exploiting AI a lot on designing the network, because this is usually something that is made by humans. But we see that the industry is starting to work on some tools to assist the engineering also in the network and the service design, which is very powerful, because it can collect the requirements, the demand coming from the users, and to be able to propose some alternative scenarios on how to set up a network. I remember when I started the network in Open Fiber, I had to build the transport network, the national backbone, and the aggregation network. It was a kind of design that was manually made by us. The expectation that the AI will also help us in designing the network in a more resilient way, and also in a quicker way, and therefore in a more efficient way.
So not only maintenance, but also network design. That's what AI is probably capable to do, either now or in the near future, right?
I would say in the near future. That's a hope. Okay.
Very good, in line with the panel. So Petros, same question. Solid and fruitful application in your industrial experience.
Yeah, so there's a range of applications and a range of levels. I think, with the current state of LLMs, one of the first things that we actually implemented and is working is we have a lot of big technical manuals that a lot of our contractors need to, ideally they should learn by heart, which they don't, of course. But they need to use to install and troubleshoot our systems. And our customer service can get overwhelmed, especially at periods of high demand. So we have a lot of LLM type products that can actually look at those manuals and help the contractors look for fault codes and things like that, and help them assist them in installation. This is kind of the more applied level. Of course, we use a lot of machine learning and LLMs in our operations. Even at the research level, helping us with coding and creating slides and all that. But that is more what people understand, as common uses of ChatGPT. They've seen that, they know it. Going a bit more to the more kind of looking forward and research side, I think we're starting to see one of the difficulties with factory automation is how do you train robots to do tasks? How do you tell a robot, pick up this equipment and put it there and connect these things? Trying to use machine learning to create the steps for the robot to enable the robots to do learn tasks more easily with a human instructing the robot, or maybe mimicking a human, things like that. So this is very promising area. Also for personal robotics and health robotics, for example, robots that work in houses and things like that, incorporating LLMs, but also doing it in a way that there is some guarantee and some effort to make sure that the LLM doesn't misbehave. Going back to the hope or hype or risk, we need to, it's one of the risks, absolutely. So we're working on that. In the sensing area, we see a lot of promise in areas where we don't have good models. For example, a lot of radar sensing indoors, which very often we need to for privacy reasons. We cannot put cameras. We found that using models to train, using data to train models, we can do very good sensing. We can get pose estimation, position estimation, things like that. Even though we don't have good analytical models to do that, and that works quite well. And then finally, going to a similar problem, the design problem. We've seen a lot of success using machine learning, physics-informed machine learning models to design, for example, motors, or help in the design of motors, or things that are kind of a bit more freeform, and a bit more ill-defined as a problem. Like, how do you tell an engineer, go design a motor, right? And there are many options, many choices, and not discrete. It's not a discrete optimization. So we've seen that networks can, AI and deep networks can help there. So there's a big range from the immediate to the still in the research stage, but we've seen a lot of impact, and we think going to hype or hope. I think it's a bit of both. Some things are certainly overhyped, like AI is going to take over the world and control us like we're puppets. But there is a lot of hope in a lot of applications that we've seen.
Terminator scenario,
yes.
Right? But are you developing AI in your company, or are you using AI taken from, I don't know, external companies or research institutions or whatever?
The answer is yes. A bit of both. So we're not developing LLMs right now. LLMs are generally very difficult to train, so there are a lot of LLMs that we can use available. But a lot of other AI techniques, like for example, agents on top of LLMs, or deep learning models that are trained, physics-informed neural networks and things like that. We are developing new models and training new models from scratch, or fine-tuning models, fine-tuning LLMs, things like that. But as of now, at least at Merle, we're not training like LLMs from scratch.
Thank you very much. Now, Lou, again, fruitful and solid application. We already showed some in your statement, but please elaborate again.
Thank you. I think I think a communication area, it's a bigger area related from physical layer to network architecture. So But I just want to show another example of this, what is already implemented in Huawei's product, which is like the network management system. So we have already defined the autonomous level from 1 to 5 for the network management. Take 5G slicing feature as an example. So slicing is defined in 5G to provide a customized network for the industry, even for the high-end customers. So in case we need to configure these different features of network, there will be 1,000 pages of the book for the network management engineer to do. But with the help of the AI, it can be very autonomously configuration for these parameters, and the network manager just needed to import the requirement and what is expected result for the network, and the AI can autonomously provide such services. So this is an example of what we already implement in our product. But in future, which means that if we consider we need to satisfy new features like the robotics mentioned by colleagues, and also like the virtual reality applications, which means that we need to bring these new features to 3GPP again to define these specifications, which will be a large cost for our to develop new features. So based on AI, especially like the agentic based on AI technologies, we think that it will be very good to have this application-driven network for the next generation of the work. So which means that if there comes new requirement, the agent will define the new profile for the network and generate these features depend on the requirement of the applications, like take the robotics as an example. So for robotics, the network may need to provide some URLC-like communication with more reliability to control the systems, and also may provide network sensing for these environment reconstruction. So based on these requirement of the combinations of the network features, so the agent can define these things and generate this network thanks for the large language model. And we also do some fine-tuning and to fit for the network. And in that case, which means that we don't need to bring every new requirement to 3GPP. And 3GPP just needed to define the how to communication between the agents and also between these framework. And in future, the network can be generate new slides or new features based on these requirement of the applications. This is something we are now research, and we also have some POC and try to discuss in 3GPP to hope that can be a feature of tomorrow.
A truly intelligent network, right?
Yes.
Difficult question for you.
Okay.
Sticking to 5G or even projecting to 6G, we are all researching nowadays. Can you rate 10%, 20%, 30% the relevance of AI into research and or into business? That's very difficult, but your guess. You're here as an expert, so your guess. We trust you.
So, to be honest, this is a very hard question. I think that's not.
I knew it.
Yeah, because why we are from communication society, we are now also learning for the AI, but AI definitely developed very rapidly. So maybe today I can say 10%, but maybe there's some next round of exploration of this AI technology. Then the rate can be 20 or 30%. So for me, I don't have the clear answer now. But to be honest, we think this AI will play a real important role for the network. It is not only for example, the AI can be a tool for network, but network should also learn how to satisfy the new AI features, like embodied AIs. Yes, we need to design the network feature to fit these new requirements. So
Very good, thank you. Now we go to the next question. The conclusion of the first question was hope or hype. It's a little bit of hype, a lot of certainty, and of course of hope for the future. But now we go into the second part of the title that concern risk. We heard from all of you that AI is already doing design, right? Not just maintenance or check or whatever, it's doing design. And also it's doing network shaping, network configuration, right, by itself. So one of the risks that I will ask you to comment is, will it lead to dehumanization? Many jobs that are now of young engineers, and I'm saying to you, young researchers, many jobs that are now devoted to young engineers will in the future just be eaten up by artificial intelligence. That's one part of the risk. And the other risk, we all knew this, especially for large language models, is sustainability. The power consumption worldwide of artificial intelligence is, okay, a few percent now, but is growing at a phenomenal rate. So in the future, we are all wondering if it is sustainable, the ratio between costs and benefits, and so on. So read here, I'm asking to you, what is your view on the two aspects that I have briefly touched upon? That is sustainability of artificial intelligence at large, and also possible dehumanization for all of us, even us in research, because sooner or later, AI will be capable of doing research in our place. You first.
Okay. Thank you. So I think this is also the this is a very good question, to be honest. So based on our design, especially for sustainability, for the energy efficiency, and also for the opportunities. So first, maybe I will come from the sustainability part, because from my understanding, yes, if we want to train a model, especially for this very big model, we do need a lot of electronic to support the model of training. But the thing is that we need to think about the final, and from end to end to think about the task we finally finished. Come back to the example of the network configuration. So in case we use the traditional way, there's manager, the network engineer who works on this, maybe he need to have hours to finish all the configuration and also finish the test. But with AI, that can be even finished in minutes or seconds level, which means that those we cost some electronic for the training, but actually it improves the efficiency of this end-to-end task. So which means that from the whole balance part, we think that we still need to consider to use these new advantage technologies to benefit more. But meanwhile, for the sustainability part, I think we can find some balance in future about this cost and also the real benefit we can get from AI.
This will be more and more automated, then there will be no human intervention at all.
Yeah, this is the second question I want to answer is for the human-related issues. Like, I think even for me, I'm actually when I was graduate, I was a communication engineer. Yeah, so now I am also beginning to learn more AI. So which means that I really don't think that AI will destroy the new jobs or new opportunities. It is like new tools. Like before, we don't have electronic, right? When the electronic is invented, actually the whole industry has jumped and even provide more job positions. In this case, I think like what we mentioned about sustainability, which means that maybe in future, the new energy or green energy will be a more important, play a more important role. Maybe these domains may provide more opportunities for the young people, for young generations. Maybe there will be some change from this from one domain to another for these new positions right? So in this case, I think AI will be definitely a nice tool to have, and it is can to bring a new, maybe we can say this drive or this new echo for the whole industry. But I think it can also bring more chance in some domain. Like if we do want to improve these energies, can we consider new green energy, more efficient green energy, and also like for computation, whether quantum computing will be a new way to improve and fit for AI. So this is, I think all the industry will find the solution.
So your view is very optimistic. You say we spend some energy in training, but then it will be so optimized the network that overall you are saving even energy, right?
Yes.
You share this vision?
More or less, I think, I'm not sure about the total energy networks and saving in the networks because it's not my domain of expertise, but I feel that I do agree that machine learning, AI right now is terribly inefficient, but I think we're making very good strides towards making it more efficient. We are trying also in our company, we recognize this as a problem, but I think the world recognizes that. People understand that, the big companies, especially when they have to pay their energy bills, when Microsoft recently, announced that they're going to revive the 3 Mile Island, the nuclear reactor, in order to be able to...
raising some concern, right?
Right, but in order to be able to power the data center. So they see the impact in their bottom line as well, not just, it's not just theoretical. And I think a lot of companies are working on we are working on making cooling, for example, more efficient. A lot of companies are working on making the algorithms themselves. We're also working on that, more efficient.
Whole line of research on
parameters.
sustainable AI, right?
Exactly. There's a lot of work, and I think there's a lot of opportunity there, which I think will reduce the total energy cost. So in some sense, yes, it is right now an issue, but I think in the long term, we will see good solutions that will not be as problematic. And I think a big part of the cost is the training. Now that we kind of have models that work well, I think the evaluation could be a lot more efficient, and there are specialized processors and so on. And as these things are being deployed, you will see evaluation and inference much more than training. So I think the energy cost of that is not as big. Now going to your other...
Humanization.
The humanization, I think any technology when it's introduced creates some job losses. People used to do manually saw things, and now we have sewing machine, right? And things like that. Like now we have robots in the factories. Of course, we need to be careful with who is displaced and how we can retrain them, and they can move to a higher level of job function. And that's not always easy. But I feel that machine learning and AI will just create new opportunities. For example, I'll give you a very trivial example in coding and programming. We've noticed that we used to spend a lot of time in coding a lot of our algorithms. Now we spend a lot of the time debugging the code that AI generates, right? So it just shifts the problem to something else. And I think you'll see that more and more, that jobs are going to a higher level. Of course, there's going to be disruption, but I don't think it's going to be that massive unemployment that some people predict. And I think it's something that is manageable. We're also seeing a bit of a plateau in the capabilities in practical systems. So I think a lot of those predictions were based on the hype that AI can do everything, but it seems that there is a ceiling right now, and we need new fundamental methods to overcome that ceiling. And until that ceiling is overcome, I think the disruption is going to be much more contained.
Does your company have special paths for training of young people in AI? Because currently not all academic training is centered on that.
So I can't speak on behalf of the parent company, Mitsubishi Electric. Yeah. Our company, Merle, which is the research lab, we typically get PhD students who are already trained in learning. But a lot of our researchers, because they're researchers and they're doing fundamental work, For them, they had to learn either through courses or, we send them to conferences, tutorials, things like that, and we support that. Every single person in our company now is using AI in their research. I don't think there's a single researcher who does not touch deep learning.
That's what I was saying in my introduction.
Right? So it's, you learn by doing, you learn by taking courses, you learn by going to conferences. Now, in the parent company, I don't know exactly what's happening, so I can't speak to that.
Thanks a lot. Domenico, dehumanization? Are you firing people because of AI?
Well, personally, I don't believe in dystopic scenarios. All the narrative about AI. I think that we can be in fully control of AI. Once again, it boils down to education, to have a proper AI literacy. I think that the AI Act, the European regulation, is working in the right direction, recommending an extensive education starting from young ages. And that's an initiative that many countries are going. I think that Italy will soon also going toward this path. That's what we are starting to do in Open Fiber. We believe that to avoid the dehumanization, all the narrative also about unemployment. If you take the latest figures of unemployment rate in US, you compare with the prediction of some years ago about the jobs disappearing. I mean, there's a discrepancy out there because I mean, there's not such a correlation. I think that you must work on delegation, description, discernment, and diligence. Once again, 4D. So you need to train the people inside the organization to scale up AI inside the organization and to understand the potentialities on these four skills. And also other soft skills like critical thinking, creativity, some intrinsic skills that are intrinsically human. There are some tasks that AI are doing right now better than humans. For example, in pattern image recognition, there's no question of it. But I think that the human must govern the trend.
Sustainability.
Well, about sustainability, I think Open Fiber, of course, is very aware about sustainability. You think we built a network in Italy which is based on FTTH fiber to the house network. Fiber is intrinsically a green network because of the carbon footprint and the low power consumption also on the residential side, on the CPE of our customers. I mean, we are building a future-proof network that can be easily scaled up without messing up. So just working on the edge of the network, you can scale up easily the capacity without any impact in the environment. Of course, I read about the high consumption of AI algorithms, specifically in the training phase. And I mean, the figures and the data you see about the consumption for a query compared to a simple browsing are really mind-boggling, for sure. But I think I personally have an opinion that once again the solution will come from neuroscience. We started the AI many years ago in the 50s, leveraging on the output of the neuroscience and with a deep understanding of how the human brain works. Myself, I read something about neuroscience at that age, and I'm impressed by how neuroscience was advanced in the early years of last centuries. And of course, if you compare the comparison, I mean, our brain has trillions and trillions of neurons, and it's just has a negligible consumption, and few watts compared with the eye. So maybe the answer will come analyzing once again how is the structure of the human mind.
So it's very good to hear your optimistic views of the...
Very optimistic.
But
very optimistic.
Everybody, every of you. Now, a final, very quick round of questions, just a few words on this, about, you keep it, about the evolution or revolution. Some say that research on AI is already over. Now it's just the time for application. So let me read it. Do you think the application of such techniques in your field is going to represent a real revolution? Is the progress still on, or it is already reaching maturity? Compared with big data, 10 years ago, everything was big data. Now big data is almost forgotten. Will it be the same sort of fate for AI? Just a few words. And then perhaps some questions for the floor after this final quick round.
Well, I would recommend to the audience to see the Gartner perspective. Gartner has a methodology called hype cycle, where for a technology it shows how the adoption is increasing, the hype, the slope for disillusionment, and then a plateau of productivity. In which phase are AI at the moment, according to Gartner? I think that it's curious to see that specifically on data, on the structure of data, is in some disillusionment, there's some hype, and so I think that a lot of work has to be done in structuring the data, because I see, for example, in our work, we have many means, many channels of information, also analyzing the information that we collect from the network. And the real task is to prepare the data structure to feed the AI algorithms. AI algorithms are proceeding at full speed. There's also, I read an interesting article that say that if the research of algorithms of AI had been interrupted in this moment, for the coming 4 or 5 years, if there will be some additional benefits, but we must work on structuring and to train AI properly and to get the full potential of it.
Thank you very much, Petros.
Thank you. That's actually a very interesting question. One thing we see with a lot of technologies is that there's the hype, businesses adopt them, but then it actually takes a very long time to see the actual improvements in statistics about data. For example, internet. We know now everybody's using internet. Amazon, all those companies. It's everywhere. But it took a very long time from the beginning of the internet becoming public and publicly available before you could see the impact of computing and internet and networks in the statistics for the economy. I think AI is kind of at that stage right now. So I think there's a big, there's going to be a lag before you can see AI applications actually having an impact in businesses. I think part of it is we know what AI can do. A lot of business processes need to be adjusted to that, and also AI needs to be adjusted to a lot of business processes, which I think, it's not a research for kind of our community, but it's a research for like the business community, and it's actually a very important problem. And then there's also the question of, energy efficiency, the plateauing capabilities, which we are observing in reasoning. I think a lot of people are observing that reasoning has not improved with the latest models. So a lot of research there. So I think there is a very big opportunity for widespread adoption. I think there's going to be a lot of flops, but also a lot of successes, and it's going to take an effort. So I don't think we're at the stage where we can say it's reached the mainstream and it's everywhere and we're done.
But there are some signs of saturation, right?
There are definitely signs of saturation. So I agree with the hype cycle that.
Thanks so much, Lou.
Thank you. So I think I share similar views with previously experts. So generally speaking, just have a quick summary from my side. So this, even in our communication systems for the network, this AI should, we have some product, but generally speaking, it's still on the very beginning. So we consider, especially from two aspects. First is the AI itself, because now we use large language modeling. It's mainly based on transformer, but whether it is suitable for communication system, we still need to consider like the transformer or diffusion or or some models, and whether some of the part can be explainable to improve the performance, or even consider how we can think that a system can be more reliable and resilient. This is for AI itself, and another is for data. Now I think based on the large language model, the data is mainly from the internet, and the high quality data from internet is already integrated or trained for this model. But for our society, so for the communication side, for this new, for example, sensing like the similar like the radar sensing, these new data, how actually I think it's at the very beginning stage to fit for this new model. We need to fine-tuning these models. So from these two aspects, we think that AI is not ready for everything, definitely. So we still have more space for research for the product. That's my summary. Thank you.
So please join me to thank our distinguished speakers for their participation and their insight. And we have time for a couple of questions from the floor. You ask the question, then any of you can take it. Any questions? Yeah.
Okay, so thank you for the interesting discussion and for sharing your views on this. In our research, conferences, papers, we always mention some problems in AI. Typically, explainability. Another is security. And maybe some others that are always there. For instance, certified guarantee on the performance. So this is something that we usually discuss in our meetings, in research, in academia. Are these real problems that you perceive limiting the adoption of AI in your companies? Or maybe you don't care about, I don't know, explainability. If things work, they work, and then we don't care about explainable. Are these real problems or not?
So the issue is security in AI.
Security, explainability, I would say more explainability, yes.
You hear me? Oh, there, yeah. Since we have a broad range of applications and products, maybe I can start with that. I think the answer is depends on the product. For example, if you have an application where, if it's something like a simple search or a translation, even if you make a small mistake in a context, maybe it's okay. And maybe you don't need to explain how the translation exactly works. But for example, we have a lot of algorithms that are based on learning, which we need to guarantee like the safety of a robot, that it won't just go crazy and start hitting you, right? Because you're working together with a robot. In those cases, we have a lot of work on trying to put controls that are more classical and give you those safety guarantees and control the AI. And then there are other questions, which is if you go to LLMs, you want to try to look at explainability. This is not something we know how to do very well. We also don't know how to control LLMs very well. But I think a lot of it depends on the application. So for many applications, safety and strict guarantees are very important. For others, they're less critical. Now, I want to say something else also. A lot of emphasis has been placed in the community, and I'm of that kind of upbringing and mentality, that we need to have good, strong theoretical guarantees of safety and security and so on. But in fact, if you look at real-life scenarios, those theoretical guarantees are relying on models and assumptions that might not be true in real life. So really, sometimes they're, I don't want to say meaningless because they give you a good sense of what's happening, but they're not enough. And for example, when we talk about humans, are humans, do they have any guarantee that some driver, and we see all the time, won't do something stupid and go crash? How do we guarantee that? Well, we have a lot of history of humans driving, and we know that if we have a driving test and some policing and so on, we can control that and reduce the risk. I think some kind of approach like that is needed on systems that we cannot fully explain. So there is a theoretical guarantee, but on top of that, we need to have a bit more kind of experimental and guarantees like that. Now, this is not an easy question, and I think there needs to be also theory around that, on how you design that, but I think that's important.
Thank you very much for the interesting panel. The question is for Domenico. You have commented about the training in your company. Can you be more specific? Which kind of training to the employee?
Okay, yes, so this is an initiative that we started this year. It's not correlated to what's going on in the AI Act, on the recommendation coming from the European Commission. It's an initiative that we took ourselves. We've been working with people, with HR department, and we started with a training, which was kind of a technical training. So the participants to the first sessions that we made this year were basically intended for training engineers and operators on the principles of AI platforms, the architectures. So we explain what is a generative AI, what is a LLM, what is a RAG, what is a variational encoder, all the main architectures of AI. So it was a really on the technical side. Then smoothly we introduced also some concept on prompt engineering, and we made we've been making some hands-on sessions on comparing the different bots. So how was the response of Claude, Perplexity, ChatGPT, etc., comparing, and to be able to be critical, to understand how the same platform, the same question was answering, and how can you better structure the questions to have a better output. So all this convinced us that it's essential to start now an overall and extensive program of training for all the organization, not only for the engineers. So we will train people in communication, HR, of course, it's imagine on the recruitment department, which is the impact of AI, but also marketing, commercial, customer care. So we are now tailoring an AI course where is intended for the public, and also speaking about the AI Act, speaking about the importance of AI literacy. And so, of course, we will give some examples of the principles of AI, but it would be a cross-intended program for the publication. And then, based on the feedback, we will see how to make some adjustments. But we are really convinced that you must start this initiative for the overall organization. Then we'll see, of course, what will be the outcome. But we're very enthusiastic about that.
Perhaps one final question, because we're running a little bit late. Please.
Thank you. Thanks for the very interesting panel. I have a general question regarding let's say, the future of the development of AI applications for industrial use cases. So currently, models are getting bigger and bigger, and data is getting larger and larger. But actually, more than creating more intelligent models that try to generalize to unseen data, we are trying to build models that with data that includes all the possible available data, so that there is no out of distribution data. So do you see the future specifically for industrial applications on which maybe data is scarce or not widely available as text on the internet, for example? Do you see the future is building larger models, or maybe building more intelligent models that are more data efficient?
Larger or more intelligent? That's the question.
So I think actually what our work, just from my thinking, it's like not maybe only one very big, large model, but we think that maybe in future the distributed of this model will be an important way, because why we think we need to define a framework to enable these, some of the, maybe even we can say some of the intelligent model maybe near the edge or at the mobile phones or at the end user, but we see the bigger models deployed in the center. So benefit of this is can benefit for the privacy, and because exchange of different models can be token based, and also to contribute to establish the whole intelligent system. So we, from our consideration, it will be not only one big model or only distributed. It should be the hybrid way. It's maybe the better solution. Thank you.
So thank you, Domenico Angotti, Petros Boufonos, Lulei. Thanks again for participating into this panel. And the coffee is waiting for all of us. Ciao, to the next.